Welcome everyone! Today we learn how to combine asynchronous streams with parallel processing in C#. So go to Visual Studio and create a new ASP.NET Core NT project, define the name, select the .NET version and create the application. Imagine that we want to collect data from temperature sensors of multiple IoT devices as soon as they arrive in our system. Each IoT device sends temperature data with some delay, so we'll display the incoming temperature data as soon as possible. For this reason, we'll use IAsyncEnumerable, which is a feature introduced in C#8 to handle asynchronous streams. So go to the program.cs file and add a new method, which will be static and will return a new IAsyncEnumerable of type string to show the temperature in a message. Define the name and we'll define two parameters. The first one will be the device name and a second parameter which will be the number of iterations that we want to measure the temperature from the IoT device. Let's define a default value of 5, add a new for statement based on the iterations or times, and we'll use the delay method from task to simulate the response from the device. So we'll set a random value from 1 to 5 seconds. So create a new random object and use the next function to define the minimum and maximum values. So the maximum value is exclusive, so let's set it as 6 and multiply this value by 1000 because this delay is displayed in milliseconds. This will be the device response time, and create a new variable called temperature. So we get the temperature from this sensor after some delay. So let's randomly get the temperature from 10 to 20 and let's use the yield statement to return the value as it becomes available. So called yield return, and we'll display a message. Let's apply interpolation. So the device based on the name is reporting a temperature of and pass the temperature value. Now create a collect data endpoint. We'll use this default endpoint to display the temperature messages as soon as they arrive. So to consume an IAsyncEnumerable, we need to add the await keyword in a for each statement. So add the await and create a for each statement. We'll get the temperature and call the collect data method and define the device name. Print via console the temperature message and add in the beginning of this endpoint a message starting to collect data, and at the end we'll add a message that the process is finished. Let's run the minimal API. Open the console window. As you will see, we're receiving temperature data from the device A with some delay. We're asynchronously receiving the data from this IoT device. So after 5 iterations, the process is finished. So we receive the data as soon as it becomes available. Close the API. We also want to collect data from multiple IoT devices simultaneously. So to accomplish this goal, we'll use the Parallel.ForEachAsync operation to run tasks in parallel. We'll use the asynchronous version to prevent blocking the main thread. So let's create a new list to define the device task from multiple IoT devices. So add a new list and we'll return the IAsyncEnumerable collection of type string. Let's define this name as device task and we'll create a new list and we'll reference the collect data method. We'll collect the temperature data from 3 IoT devices simultaneously from I, B, and C. Now write the Parallel.ForEachAsync operation. So this is an asynchronous operation, so add the await keyword and call Parallel.ForEachAsync. The first parameter from this operation is the device task. And then we'll define a new parallel options. In this class, we can define a max degree of parallelism, which is the maximum number of concurrent codes. So we'll define it as 3. And finally, we'll define a new lambda expression with 2 parameters. The first parameter is the device result from the list of IAsyncEnumerable and the cancellation token. So move this await for each statement inside the parallel for each body. So instead of iterating this collect data, we'll get the device result, the temperature from the device result. We'll run 3 tasks based on the IoT devices in parallel simultaneously. So let's also display the temperature data in the endpoint response. So create a concurrent back object, which is a thread safe on all the collection of items. So define a concurrent back object of type string. Define a new instance. So inside the for each statement, we'll add the temperature in the back. And at the end of the endpoint, we'll return this back in the endpoint response. Now run the API and see the behavior. Open the console window. As you will see, we're reporting the temperature simultaneously from 3 IoT devices randomly because we're handling some random delay. So as you will see, as soon as the temperature is available in any IoT devices, we're reporting the temperature. And when the process is finished, you will see in the minimal API endpoint that we have all the temperature data in the endpoint response. This is an unordered collection of items. So as you will see, we're combining asynchronous streams and parallel processing to display temperature data of multiple IoT devices simultaneously, and they are displayed as soon as they become available. Close the API. Finally, let's learn how to cancel an enumeration. So scroll down, and in the collect data method, we'll add a new cancellation token source object. And from this object, we'll define that after 10 seconds, we'll cancel the process, the enumeration. So we'll pass the token from this object in the delay method. So in the second parameter, we'll pass the token from this object. So after 10 seconds, we'll cancel the enumerations. We'll start processing temperature data from any IoT device. Let's save it and run the API. Open the console window. As you will see, we have the temperature data from multiple IoT devices. And after 10 seconds, the enumeration is canceled. In this case, is canceled from the device B. And for the other devices, the task is canceled. Close the API. So in this demo, we've learned how to combine asynchronous streams with parallel processing in C#.